Hi all, this is Divya from Sri Samudha Educational Institutions. I am working as assistant professor in the Department of Biomedical Engineering. Today let us discuss about the topic mesh analysis in electrical circuits by understanding Kirchhoff's voltage law and the circuit currents. So what is meant by mesh analysis? A method for analyzing planar electrical circuits. The circuit should be planar and it worked depend upon the Kirchhoff's voltage law. So the Kirchhoff's voltage law is sum of potential drop is equal to sum of potential rise. So it is used to find currents in each mesh. So mesh analysis is efficient for circuits that have many loops but fewer nodes. It helps simply solving for currents by writing KVL equations. So here the Kirchhoff's voltage law is the sum of potential drop is equal to sum of potential rise. So basic concept we are using here is mesh. First thing is, what is mesh? A loop that does not enclose any other loop. So the loop that does not enclose any other loop. So loop is a closed circuit which does not contain any other loop. So loop means any closed path is in a circuit is called loop. So KVL, the sum of voltages in the closed loop is equals to 0. So this is KVL statement. KVL states that algebraic sum of all voltages around a closed loop is 0. So KVL is essential in mesh analysis. It ensures voltage rises and drops balances around any loop. That means the voltage around a closed path is the summation of voltage around a closed path is equal to 0. And steps in mesh analysis. So what are all the steps we have to follow in mesh analysis? First you have to identify the meshes, how many meshes are there, and you have to assign the mesh currents, and you have to apply KVL to each mesh, and you will get simultaneous equations, and finally you have to solve the simultaneous equations. So first step is you have to identify the number of meshes and you have to apply the mesh currents. So if the mesh currents direction is already given, you have to use the given direction. If it is not given, you have to assume it in clockwise. So once the current direction have been assumed, you have to apply Kirchhoff's voltage law to the each mesh. So here you can identify, you can see the two meshes in the circuits. So here you can get two currents. So this is an example problem to solve the mesh analysis. So in the circuit you can identify the two meshes, so two closed loops, two meshes here. So you will get two mesh currents. So you have to apply the current direction for the meshes. So for first mesh you have to apply the current direction as I1, and the second mesh you can mark as I2 like this. So I1, so they didn't give any current direction, so you can mark in clockwise direction. You have to mark in clockwise direction. And here I2, so that direction also not given, so you can draw as in clockwise direction. So here you can find out in the first mesh you have a voltage source and 3 resistors. In the second mesh you have a voltage source and 3 meshes. Now you have to apply KVL for this one. So how can we apply KVL for this one? So KVL is nothing but Kirchhoff's voltage law, that is sum of voltage drop is equal to sum of voltage rise. Around the entire closed path, the current value should be, that is the voltage value should be is equal to summation of voltage values should be is equal to 0. So how can you find out voltage across a voltage source? So look at the current direction. flowing through the voltage source. Here voltage source. So here you can find out 3 resistors. So 3i1 and in the resistor 5, 2 currents are flowing. Both the i1 and i2 are flowing. So you have to write as i1 my 5 into i1 minus i2, and through the resistor 6 ohm only the current i1 is flowing. So you can write as 6i1, and here there is a voltage source. So voltage across a voltage source is nothing but the value of the voltage source. You can write as 50. You can write as minus 50. So by solving the equation you can get, so totally 14 i1s. Coefficient of i1 is 14 and coefficient of i2 is minus 5, which is equal to 50. And now you got the two equations. In the same manner you can get the equation for the second mesh also. We got the two equations. Now you have to solve these two equations, two simultaneous equations, to get the value of i1 and i2. So for solving the equation you have to get the coefficients as same. One of the unknowns coefficients should be same. So how can you make the coefficient same? So in the first equation the coefficient of i2 is 5. Second equation the coefficient of i2 is 15. So you have to make the i2 coefficient in the first equation as 15 by multiplying the whole equation by 3. So if you multiply the equation you will get 42 i1 minus 15 i2, which is equal to 150. Now you can solve the equations. Then minus 15 i2 plus 15 i2 will be equal to 0. So the final equation is 37 i1, which is equal to 125. So i1 is equal to, so by solving i1 is equal to 125.